Ryan with Miss.Geek here, and this video is more of the DC40 version 2 improved version from Steve Ratzlaff, and I don't know if I've actually linked to this yet, and I'll link to it below. This is the Steve's version, AE7 Uniforms version of the DC40, and there's some differences I noted when I went to go looking for parts because it's getting time to build here, and so I want to talk about that in a minute. But I noticed that the capacitor values were different. So over here he's got a 47 microfarad. See, I haven't grabbed that yet, but 1 picofarad, 1 microfarad, 1 microfarad, 1 microfarad. But here he's got 33 microfarads. So, and this one's he's using an electrolytic. So I grabbed one of those. I grabbed back of those 0.47 microfarad instead of 0.1 here. 0.47 here is on both. So, and he goes for a 47 here on both these, same as this. So it's all pretty much basic. Now, to build, we need some parts. So I have a selection of electrolytics that I bought on Amazon, and so I need 3 different kinds, 33 microfarad, 47, and 0.47. So that's these. So I'm just going to set these up here out of the way. I need a 40 megahertz bandpass filter, so that's what I've got here. When I built these, I put 4 dots on the side. That's the easiest way to tell because the underside's usually kind of messy. And I didn't have a labeler at the time. So I just wrote 4 dots on the side. So there's my 40 meter bandpass filter. Need some 2N2222s. So these are actually 2N3904s. Same thing, good enough. And then we've got the LM386 module. Got that. Now, because I'm using the QRP Labs filter, what I'm going to do is I'm going to use these to make it really easy to mount. So I've got these sockets here, and of course I just store these pins with them. So I've got those. And the only thing that I haven't grabbed yet is the 0.1 microfarad. Well, let's see here. Make sure I get this in frame here. So I'm looking for this guy. Well, let's grab the corrected one here. Looking for this guy right here. And there's a 1 microfarad there. I haven't grabbed that, actually. That's a electrolytic I need to grab. So I'm going to grab these parts, and I've got this selection, a rather good selection of resistors from Amazon. It's got 20 of pretty much everything here, and this was like, I don't know, 10 or 12 bucks. Well worth it. So if you haven't done home brewing and you don't have these kind of parts, I'll link this below, and I'll try to link the majority of what you're going to need below. And of course there's going to be some things that, you know, you're just going to have to scrounge for, but I'll do everything I can to make a parts list below, so you can just, you know, click and buy if you want to do that. But if you have you know, local people who have a parts stash, ask them if they can help load you up. That's how I've gotten a lot of my stuff. It's actually online doing that. I've had a lot of people ship me things, which is really nice. Now, for the double balance diode ring mixer, let's see here if I can bring this close. I wound 2 new FT3743s. So FT37 means ferrite toroid. I think it's 0.37 inch, if I remember right. And the metal type is 43. So FT3743. And I wound 2 of these. And I'll tell you my trick for winding those. And you can see they're using 3 different colors of wire. And the reason I did that is so that you can easily identify. I wrote them down previously as A, B, and C. You know, which part of which winding you're working with. And so I used 3 different wires, 3 different colors, I should say. And I just split them out. And the way I wound these together is super simple. I have a box of different wires. In fact, I use these containers here. And so here's all my toroids and wire and stuff. And I picked 3 different colors that were the same size or really darn close. I think they're all 26 or I think these are 30 gauge. And then I strung them together and I balled up the end on one end, and the other end I held with my pliers. And the balled up end, actually I think it's still in here, I put in my drill. In fact, I think it broke off in there. Yeah, it did. So I balled that up in there and just drilled it, you know. And I probably cut off about that much on each end, maybe about 2 or 3, maybe 2 inches on each end, because on one end it was super tightly wound, and the other end it was barely wound. So, but the middle was fine. So I went ahead and did that. And now it's time to get those other capacitors that I forgot to get together and then start building. So I'll update the video here. When we come back, maybe I'll have something built. We'll see. All right, so I've gone ahead and started on the build. And you can see I've got the QRP Labs bandpass filter here, and I've got a BNC connector here. Now this BNC connector, it's the kind that has 2 little studs that stick out, and I tore those out. They're not electrical, they're just go into plastic. And I just soldered the leads directly to the board. And then to make it nice and firm, I used hot glue. And this is fairly wobbly here. Now it's not wobbly with the QRP Labs filter installed, but without it, these 2 standoffs or sockets are quite wobbly. In fact, as I pull it out, you can just see this one move. And there's only 2 little tiny connections there. Let me turn this around and you can see. And let me see if I get this to focus here. Oh, this one's focusing, so we'll use that one. There we go. It kind of works, kind of not. There we go. So you can see I made the ground connection there using a piece of wire, and then I connected the other side to the BNC connector right there. And then the other 2 tabs on the inside are actually just standing there. And I did the same thing on the other side. So this side goes to ground, this side goes to this pad here, and this pad's going to connect to the diode ring mixer. So how am I going to make these nice and firm so that they don't, break? I'll show you. So what I've done is I've taken some of this hookup wire, which is invaluable to have, and I just basically bent a little L in the end, and then tinned it, and then soldered it to these pads here. And then there's no mechanical connection yet, but those are just for, well, you'll see. Hot glue. So hot glue, those serve as supports for the hot glue to try to tie the hot glue to those, and it kind of worked. Probably going to take a second application of hot glue, if I'm being honest. I might have to actually turn it this direction once that dries, or once that cools, to get a better connection. We'll see how it looks after it cools off. All right, so I applied more hot glue and then let it, held it this way for that side and this way for that side, so that they would be solid. And now they're nice and firm. So now, and just to be aware, with the QRP Labs filters, the filters have an in and an out. So in on one side, out on the other. They're designed for a specific kit that way, but honestly, they're bidirectional. So as long as you plug it in the proper way, with the side closest to you being ground, the signal will come in just fine. Like I said, these are completely bidirectional filters. And you can see I've also got this hot glued. And you can tell by the discoloration of the hot glue, I hot glued it a long time ago, a few years ago. Once I tuned it, I hot glued it so it wouldn't move around. And that has worked pretty well. So you can tell I really like hot glue, but it's a great tool, and a lot of makers use it. So, all right, the next thing is going to be the double balanced diode ring mixer. So this actually turned out longer than I expected. So my plan was to use the bandpass filter at 1, 2, 3, 4, 5 units long, and it is. But with this, it's actually 1, 2, 3, 4, 5, kind of 6 units long. And then this, or the double balanced diode ring mixer, what did I do with it? Oh, it's right here, is 2.5. And I could probably squeeze it in here. And I think I'm going to go ahead and try. But the antenna is on the wrong side. You can see the antenna connection there. I don't know how I goofed that up, but I did. So no big deal. I mean, A1, can I just put a jumper wire from right here? So this right here is where the signal's coming in, and it's going to go into the antenna. So that antenna connection is going to be probably right here, or even right here. So just a little wire right there will be fine. So time to get building. All right, I apologize for the shaky cam here, but I just wanted to show building according to the plan. So what I've got here, try to get some light on it. We've got it's hard to see, but we've got red, green, red, and copper colored. So those are A, B, and C. And this is the 2 side, according to this. So we've got A2 going to ground, B2 going to ground, C2 is going to go over this pad, which is where the first diode connects. On the other side, pick this up and move it around. We've got, sorry for the shaky cam here, it's just best I could do. So we have the same 3 colors. We have the copper, red, and green. And green is A1, right? So A1 goes to its own pad, which we have there. And then red goes to its, which is green is A1 that goes to its own pad, which is going to connect to the antenna input. And then, which I'll build in a moment, B1 is going to be the red, which I put nice and far out so that it'll be easy to connect to the diode ring mixer. And then C1 goes to ground right there. So it's pretty easy. Once you've nailed all this down, it's just connect the dots. So I just want to highlight that. So I'm not going to show any more until I've got this diode ring mixer built. All right, so the double balanced diode ring mixer is done. And I have to admit, I'm a little bit masochistic about how I went about the actual diode ring mixer itself. I didn't need to make it look like that, but I figure I'm working in 3 dimensions, may as well work in 3 dimensions, right? But you can see how the diodes match the diagram. And you can also see how the transformers match the diagram too. And so, yeah, that's it. So it's intricate, and I definitely needed these tweezers here. And also, it helps to be just a little bit ambidextrous for the way I did it. Now, you don't have to do it as you know, I won't even say as pretty as, just because I don't consider this all that pretty. It's just I kind of like the structure here. But you don't have to do it like I did. You can just kind of mash things down and where they go, and you know, connect pads and stuff. Do whatever. I just wasn't really concerned about saving room necessarily, but I just wanted it to, well, kind of look cool. So need to straighten these out, getting these evened out. But anyway, I think it looks cool, but does it work? It should. So the amplifier is going to connect to, get it off that little carousel type thing. The amplifier is going to connect here. The VFO is going to connect here. So we've got plenty of room for that over here for the VFO, and plenty of room over here for the amplifier, because the amplifier is, again, 3.5 by 6. So you know, here we've got easily 1, 2, 3, 4, 5, 6. So there's lots of room on this board for the amplifier. So we don't have to condense into this mess here unless we just want to. But the basically going to connect right there. So that's where the amplifier connects. So do we have 6 pads of instruction? 1, 2, 3. Oops. 1, 2, 3, 4, 5. Oops. I can't count. 1, 2, 3, 4, 5, 6. So what we do, we actually have room to put this exactly right there. Will I do it that way? I don't know. I might actually start it over here to give lots of room. So haven't decided yet, but if you have any ideas, any input on the project so far, I'd sure love to hear it. And thanks for following along. And in the next segment, I'm going to highlight some of the tools that I'm using so that you can have an easy time of building. If you've never done this before, I'll go over some of the tools I have, and it's pretty basic, honestly. So you've seen most of them already. In fact, you're looking at most of them right now, but I'll go over those next. Anyway, thanks again for watching.